And in some uranium, some biotite flakes, in some granites, we find all of these together, like the 3-ringed radiohalos. And it's very hard to see at this distance, but there are 2 rings in there. There are definitely 3 rings. Now, as I said, we can measure them and we can work out what elements were responsible for producing these radiohalos. Now, why do I say that? Well, if there's a zircon crystal in there that has uranium, we know it produces all 8 rings. So it's the element uranium in the centre, or what we call the radio centre, or the radioactive centre, that produces these rings. So when we've got a 1-ring, or a 2-ring, or a 3-ring halo, it must be an element other than uranium that's in that radio centre, that radioactive centre. Because if uranium was there, it would produce instead a uranium radiohalo. So what element is responsible? Well, it happens to correspond to the one element, but 3 isotopes of that element, polonium. Discovered by Marie Curie and named after her native Poland. It's a rare metal, and we can see it's the last 3 steps in the uranium decay chain. Now, these polonium radiohalos, because we call it a polonium radiohalo because it's parented by polonium. We call a uranium radiohalo because it's parented by uranium. Now, these polonium radiohalos, again, are found in many granites around the world. Again, whether it's in Arizona, near the Grand Canyon, or in southern Australia, in England, or here in the United States. These granites all around the world contain these polonium radiohalos. But in 1989, at a famous trial, the Creation Evolution Arkansas trial in 1989, Robert Gentry presented this information on the witness stand. And when the ACLU put up its response, the man on the witness stand was G. Brent Dalrymple, who was then the Deputy Director of the US Geological Survey and is currently at the University of California, Berkeley, in their geochronology laboratory. And in response to Robert Gentry's evidence, he simply said that these polonium radiohalos were a very tiny mystery, period. In other words, he didn't offer an explanation. He didn't have one. He didn't have one. So why are they a very tiny mystery? Well, here we're going to add some more details that I didn't add on, or didn't say much about, on Tuesday night. You see, these 3 unstable polonium isotopes only have fleeting existences. They decay very rapidly. Polonium-218 has a half-life of 3.1 minutes. Polonium-214, a half-life of 164 microseconds. If you blink, it's gone. And polonium-210, 138 days. Now, as some of you already know, it only takes 10 half-lives before you've put virtually, it's all decayed away. So for 10 half-lives of polonium-218, that's only 30 minutes. For polonium-214, that's 16.4 microseconds. And it's all gone. So how do you form a halo in that time frame? That was the very tiny mystery. What was Robert Gentry's solution? Obviously, these polonium radios had to form very rapidly. So what was Robert Gentry's solution? He claimed, and you'll read about this in his book, God's Fingerprint, that the polonium radiohalos were created. They must be God's fingerprints of creation. He concluded that the polonium had to be created in place in the granite separate from the uranium, because there was no known process that could separate or migrate the polonium from the uranium to produce these halos. And so all granites, he said, had to be created, rocks, no matter where you found them. You see, you need a concentration, a total concentration eventually of 50% of polonium to get that number of alpha decays. Now, he said it all had to be at once, but I believe he's wrong there, and I'll show you why in a moment. He concluded 50% concentration had to be there, bang, ex nihilo, when God created. Now, the problem is, of course, for polonium-214, you'd have to get that concentration within a millisecond or two, a blink. So indeed, seems to be an almost insolvable dilemma. But here's the question. Why would God create the polonium radiohalos and then allow the uranium halos to subsequently form alongside them over millions of years in the same biotite flakes? That's one problem. The other problem is some of these granites can be shown to have formed during the flood, the year of the flood. I'm going to show you one of those tonight, the one that I referred to on Tuesday night, where you can walk from fossil-bearing sedimentary rocks a mile to where the heat and pressure began to metamorphose the rock, another mile to where the rock was so metamorphosed that it started to melt and form a granite. In other words, the granite was derived by heat and pressure melting a fossiliferous sedimentary rock. Therefore, the granite could not be a created rock. It was formed during the flood. So all you have to do is to produce examples like that, and that falsifies Robert Gentry's model for God having created all the granites. So does that mean we can just throw away the radiohalos? Not at all. Not at all. They still have something to teach us. It's like any scientific endeavour. Someone puts up a scientific model, it hangs around for a few years until people find problems with it, and then they propose an alternative model. Now, someone might come up with a better model than the one I'm proposing in the next 30 years. Well, great. We're getting closer and closer to the truth. So it's not about, fighting over these issues. It's about doing better science to build better models so we understand God's world better. Because he's told us to use our minds to worship him and glorify him in exercising dominion over the world that he's given us. So we need a new model for the formation of these radiohalos. So here's the clue. Since polonium is a rare element, where in the biotite flakes could the polonium have come from to form the radiohalos? I mean, this was the key question that struck me, that gave me the answer. You see, you have to ask the right questions to get the answers. And that's what's happening in the evolutionary community. They're not asking the right questions. But when you ask the right questions, you'll say, now, wait a minute, there is a source of polonium right there in the biotite. What is it? It's in the zircons. You've got, remember, you can see in these photographs that polonium and uranium radiohalos are side by side. Usually they're less than a millimetre apart. And sitting in the centre of the uranium radiohalo is a zircon crystal that's full of uranium. And that uranium decays to polonium. You've got a nearby source. So, next question. How do you get the polonium from the zircon crystal out in the biotite to produce the polonium radiohalo? That's the next difficult question to answer. But it does tell us if the source of the polonium for the polonium radiohalos was in the zircon crystals, that means the uranium and polonium radiohalos had to form at the same time. And that's a very important lesson that we concluded on Tuesday night. Why is that? Because that means to get enough polonium to produce a polonium radiohalo at the same time as a uranium radiohalo, you have to get 100 million years worth of uranium decay in just a matter of minutes